At the end of 2024, researchers warned that the underwater volcano off the Pacific Northwest could erupt by late 2025.
We usually talk about the weather above the surface, but what if I told you one of the most active volcanoes in North America is actually underwater?
What if I told you something massive is building beneath the Pacific Ocean? Something so strange, so powerful, and so unexpected, it's making even the world's top scientists uneasy. Today, I'm bringing you a story that's not just shocking. It's potentially game-changing for everything we thought we knew about our planet. Forget everything you've heard about earthquakes, volcanoes, and deep-sea mysteries. Because in 2025, the Pacific is hiding something big. I'm talking about radioactive signals, where no one expected them, ancient crust shifting in ways we've never seen, and most terrifying of all, a silent undersea volcano that might be preparing to erupt this year with absolutely no warning. This isn't science fiction, it's real, and it's unfolding right now beneath thousands of feet of water. Researchers from the University of Toronto and multiple seismic labs have been tracking a mysterious pressure dome rising under the ocean floor. And guess what? It's growing fast. Alongside that, scientists have detected isotopes, normally associated with nuclear material, embedded in layers of crust that are millions of years old. These aren't leftovers from human activity. They're natural, and no one knows how they got there. In today's breakdown, I'm diving into the most disturbing seismic anomalies we've seen in decades. I'll walk you through the exact coordinates of this geological event, explain how this ties into rising tectonic stress, and why experts believe the seafloor itself could be signaling something far more serious than an average quake or eruption. This is not just another tremor. This could reshape entire coastlines if it plays out the way some models are predicting. So stay with me, because what I'm about to reveal might just change the way you look at the ocean forever. Ready? Let's dive in. A sleeping giant, the Pacific volcano Awakens. What makes the axial seamount uniquely dangerous isn't just its proximity to the US coast, though it sits only about 300 miles west of Oregon, but how it connects with the broader tectonic systems beneath the Pacific Northwest. It's not a lone wolf. This volcano is perched directly on the Juan de Fuca Ridge, a mid-ocean ridge where new crust is constantly being formed as tectonic plates slowly pull apart. But here's the twist. This ridge sits between two enormous plates, the Pacific Plate and the smaller, but critically important, Juan de Fuca Plate, which is actively subducting beneath North America. That subduction zone, if you've heard the name, is the same one that powers the infamous Cascadia subduction zone, the one scientists say could unleash a magnitude 9.0 megathrust quake someday. And now, axial is becoming more volatile at the same time stress seems to be rising across the Cascadia region. That's no coincidence. Many geologists suspect that magma movement beneath the seafloor is part of a broader tectonic process, a shifting of deep energy, one that doesn't follow borders or neat categories. Volcanoes, earthquakes, crustal stress, they're all interlinked in a massive dynamic system. Let's talk about the implications if axial erupts this year. First, a full-scale eruption could send superheated lava rushing across the ocean floor, melting, displacing, and fracturing it in real time. This could destabilize nearby slopes, and if a submarine landslide occurs in tandem, as some computer models are now suggesting, it could displace enough water to generate a tsunami, even if it's a localized one. Coastal cities like Newport, Coos Bay, and even parts of Northern California could feel the impact, especially if warning time is limited. Second, the eruption could trigger seismic responses farther inland. It's rare, but not impossible, for large undersea eruptions to alter regional stress fields, slightly nudging faults that were already close to slipping. The big concern is whether all of this points to something more coordinated, a tectonic chain reaction that might stress adjacent fault systems, including those running inland beneath Washington and Oregon. And finally, there's the timing. With 2025 already producing strange seismic behavior along the entire Pacific Ring of Fire, from Japan to Alaska to Central America, the surge at axial seamount fits into a broader pattern that has scientists warning this isn't business as usual. It might be the start of a larger awakening beneath the Pacific. Buried relics. What lies beneath? If an imminent volcanic eruption isn't enough, let's look even deeper into what's just been uncovered underneath the Pacific. Scientists have located what they're calling a hidden relic, an ancient layer of seafloor that's been buried for millions of years beneath today's ocean bed. If that sounds unusual, let me explain just how earth-shaking this is for the scientific community. This discovery implies there are entire slices of lost seafloor, remnants from a world that once existed, now encased like a time capsule, deep below the crust we thought was the very bottom. Previously, the belief was that the seafloor we see today was roughly as old as its deepest layers, getting recycled at subduction zones. But now it appears that ancient segments are hidden beneath modern rock in some places. Seismic readings from this year have revealed otherwise. Using seismic arrays that can sense densities and boundaries deep within the Earth, geoscientists identified a substantial structure beneath the Pacific, distinct from the overlying crust. It's like finding a secret basement in a house where you thought everything was already mapped. This buried seafloor isn't simply old, it's millions of years out of place, and far deeper than standard plate tectonics models would predict. So, how could this even happen? The answer isn't clear yet, and that's the unsettling part. It complicates everything we thought we understood about the recycling of ocean floors, the dynamics of tectonic plates, and the origins of volcanism in this region. Some researchers now wonder if there are other lost layers beneath the Pacific, entire snapshots of prehistoric Earth sealed away in the deep. Not only is this concealed strata significant in itself, it appears to be connected, at least spatially, to where the current pressure bubble and radioactive signals are being detected. Is this buried relic somehow tied to modern volcanic activity or triggering new instabilities in the crust? The scientific community is still seeking answers. Radioactive signals, the blip that shouldn't exist. Now let's talk about the next big mystery, because just as researchers were outlining this buried ancient seafloor, they started picking up something even weirder in the rock samples, a strange radioactive blip deep beneath the Pacific. When geoscientists talk about a blip, they mean an anomaly, something completely unexpected, something that should not, by established understanding, be present where it is. Specifically, they've detected an unexpected accumulation of a radioactive isotope in thin layers of ancient seafloor crust. The implications are significant because radioactive isotopes appear only through particular geochemical processes. Sometimes, their presence signals the decay of elements from deep within the Earth or points to other rare geologic activity. But this unexpected isotope is showing up deep beneath the surface, far beyond what anyone predicted for that part of the Pacific. So, what's going on here? Is this isotope left over from primordial processes, trapped beneath the surface, and now visible due to current tectonic shifts? Or is it being transported by upwelling volcanic material, an indicator of a deep mantle process we haven't fully described? Researchers don't yet have answers. For now, they're rapidly expanding their sampling range, drilling into the crust and testing more rock cores. But with every new sample, the uncertainty only seems to grow. Some geoscientists suggest that until the origin of this radioactive anomaly is understood, it could complicate models of what happens if the volcano erupts? Could radioactive gases or particles be released? Might there be broader effects on ocean chemistry in the region surrounding the volcano? The possibility of radioactive material being involved adds another layer of urgency. It's worth pondering that the ocean floor, which we see as stable, cold, and inert, is hiding pockets of radioactive energy, possibly mobilized by geologic activity now ramping up. Could this be the first sign of even deeper instability beneath the Pacific? Rewriting plate tectonics, the Mantle's secret. While attention is fixed on the volcano and the radioactive blip, geoscientists at the University of Toronto have just announced something that might change the story on a larger scale. Using a high-resolution model to map Earth's mantle, these researchers have detected strange, unexplained structures underneath the Pacific region. These unexplained structures aren't predicted by classic plate tectonics, the careful, nearly clockwork process of plates spreading, sliding, and subducting. Instead, what scientists are seeing looks like accumulations, interruptions, even vast plumes or blobs of mantle material that cluster unexpectedly beneath sections of the Pacific Basin. Why does this matter? Mantle plumes are believed responsible for some of the most important volcanic hotspots on the planet. They create lines of volcanoes, build islands, and drive upwellings that fuel massive eruptions. But the mantle structures the Toronto team is reporting don't match conventional mantle plumes. Their densities, shapes, and, crucially, their position right beneath zones of recent seismic and radioactive anomalies all suggest something is going on that existing models cannot explain. Geophysicists now have to ask, are we looking at a previously unknown type of mantle process? Could these concealed accumulations act as reservoirs, holding energy and then releasing it in bursts that trigger eruptions at timescales we haven't yet measured? Or could these blobs be the missing engines for the periodic resurgence of submarine volcanoes? As researchers chart these structures, they're starting to see overlap with the very region where the buried ancient seafloor and the pressure bubble have been found. Are we seeing layers of Earth's geological history preserved and possibly reactivated in one zone? Some researchers are even questioning whether this is evidence for a new mechanism in plate tectonics, potentially something more chaotic and unpredictable than previously acknowledged. If plate motions and volcanic activity can be tied so closely to concealed, unstable accumulations in the mantle, what does that imply for forecasting earthquakes and eruptions across the entire Pacific Basin? And could these discoveries mean that yet more hidden threats await deeper below the ocean floor? Pressure bubble, countdown to eruption, bringing the focus back to the present, deep beneath the Pacific. We're not just talking about slow, ancient processes. We're seeing active, visible signs of change. Seismic data from 2025 is showing strong evidence of a massive pressure bubble forming beneath the region, right under the volcano that scientists have been watching closely. To grasp just how dramatic this is, visualize the seafloor as a giant, slowly stretching drumhead. When a pressure bubble forms below, it pushes up, deforming the surface. But remember, the surface here isn't earth or rock you could step on. It's a kilometer-thick slab of ocean floor, buried miles beneath freezing, crushing water. Recent geodetic models, built with real-time data from sensor arrays, show the volcano's magma reservoir stretching the crust upward in a matter of months, a suddenness that in geologic terms is incredibly rapid. Seismic arrays are picking up minor quakes, tremors and shivers that radiate from the bubble's core. In addition to microquakes, there are frequent bursts of hydrothermal activity, with gas and heat signatures spiking in nearby water columns. These suggest magma is rising, volatile, and possibly reaching shallower levels in the crust. The historical record is clear. Each time the volcano has erupted in the past, it's been immediately preceded by a sharp spike in earthquakes and a distinct inflation of the caldera. At present, both those indicators are trending sharply upward. Researchers are finding that the present pressure bubble is larger and more energetic than what was measured before any previous eruption. The combination of the radioactive anomaly and the buried ancient seafloor suggests there could be materials in play now that weren't present in earlier cycles. Is this why scientists are raising the alarm? Because the next eruption could be fundamentally different. And if the big one does occur this year, will it be limited to a local undersea eruption? Or could we see chemical, seismic, or potentially radioactive effects beyond the immediate blast zone? As the countdown ticks closer, observation stations are on high alert, knowing that within months, or even weeks, we could see a major and potentially unprecedented event off the Pacific coast, the Abyssal unknown. What haven't we explored? If all this news from beneath the Pacific seems overwhelming, keep in mind, over 70% of the Earth's surface is covered by oceans, and to this day, only about 5% of the deep ocean floor has been directly explored. That means almost everything we know is based on remote sensors, occasional submersible dives, and patchy samples. So, as scientists begin to uncover these new facts, buried ancient seafloor, radioactive anomalies, enigmatic mantle structures, they're also confronting the vastness of what we haven't found. The submerged landscape of the Pacific is as alien to us as the dark side of the moon. And every time a new anomaly is found, every pressure bubble, ancient relic, or radioactive signal, it begs the question, what else is down there? Are there other sections of seafloor, even older, buried deeper still? Whole pockets of radioactive material, primed for chemical or seismic reaction? Could there be other volcanoes, larger and even less stable, waiting under miles of water? In fact, each technological advance in seismic imaging or core sampling is almost guaranteed to challenge the old models. This is why researchers, including many who helped refine our existing maps of plate tectonics, are calling these findings a major mystery. They're not just admitting they were wrong, they're realizing that even their foundational theories may need radical revision to account for what's now being seen in the Pacific. And here's the wildest part. For all the focus on planetary exploration, Mars rovers, and the distant moons of Saturn, most of our own planet's volume, especially beneath the Pacific, remains effectively unexplored. The recent discoveries, radioactive isotopes, hidden mantle structures, and relic slabs of ancient seafloor, highlight how much we're still in the dark about our own world. So is this surge in activity just a series of unrelated anomalies, or are we witnessing the first phase of a profound planetary shift, a gradual unraveling of deep Earth processes that could surface in ways we're barely equipped to predict? The unanswered questions just keep growing. The ripple effect. What comes next? Looking ahead, researchers and observers are converging on several urgent fronts, closely tracking the volcano's seismic pattern, mapping the expansion of the pressure bubble with increasing precision, extracting core samples to pinpoint the origin of the radioactive isotope, and rerunning mantle models to clarify the physics behind those unexplained structures deep below. It's a full-scale scientific effort, but under it all is a powerful sense of unease, even among the most seasoned geologists. Because while each answer seems to give rise to more questions, the pressure underground keeps mounting, and the clock to the next potential eruption keeps ticking. Let's remember, up until the 1980s, this volcano was completely unknown. How many other seafloor giants, pressure bubbles, or radioactive caches might there be, waiting undetected under the world's oceans? What happens if another one destabilizes or interacts with unexpected material? Will next year see not only a major volcanic eruption off the Pacific coast, but new clues about even larger forces at work beneath our feet? Or could data from this event force a rewriting of geological textbooks, shifting how we understand earthquakes, volcanoes, even the fundamentals of our planet's interior operations? One thing's for sure, all eyes will be on the Pacific for the rest of this year and likely for years to come. As scientists sift through every new piece of data, the sense of mystery only increases. The conventional wisdom about the deep ocean and Earth's crust isn't holding up. It's being replaced by a more dynamic, sometimes unsettling reality. And perhaps that's the humbling takeaway. After centuries of exploration, the biggest terrors and the most astonishing discoveries might still be waiting, kilometers beneath the waves, silent until the Earth finally decides to speak again. So stay tuned, stay curious, and if you have any thoughts, questions, or wild theories about what's next beneath the Pacific, let me know in the comments. Thanks as always for watching, and wishing you all a calm, seismic-free week, because if there's one thing I've learned, it's that the Earth is never really at rest. See you in the next one.